So another topic that we want to revisit is graphing linear functions. Now, if you are really good at graphing in your Algebra 2 class, you can skip this video. There will be nothing new here. It's mostly a review of Algebra 2 material. So let's begin. How do we graph a function? We already mentioned that before, that one way of graphing any function, not just the linear function, but any function, is by plotting points. So here we have a function f of x equals negative 2/3 x plus 5, and we basically make a point of values. Now let's recall that f of x is the same as y, so we could basically substitute the y in for f of x. Negative 2/3 x plus 5, that's our equation of how to find y values or f of x values. And then select a couple of points. As I mentioned before, 2 points define line, so you only need 2 points, and my favorite is 0 for the x value. That will give me my y-intercept, and f of 0 is going to be, here's the rule, right? Negative 2/3 times 0 plus 5 equals 5. So when x is 0, y is 5. Or the function value is 5 at x equals 0. So that's what we're going to be, that's the language that we use in college algebra. Okay, now let's choose another x value. And this is, sometimes it pays a little if you strategize, if you choose that value strategically. And here's what I mean by it. My rate of change is a fraction, 2/3, that will be multiplied by x. So I want to choose a value of x, which is convenient to multiply by 2/3. And what would be a convenient value? Well, multiples of 3, like 3, 6, 9, any of those. So let's choose 6, for instance. F of 6 is going to be negative 2/3 times 6, but I'm going to write it as a fraction, 6/1 plus 5. So uh, 3 goes into 6 2 times. So I'm gonna cancel out a 3, and I'm gonna have 1 left behind here and a 2, a factor of 2 left behind there. So that gives me negative 2/1 times 2/1. So basically it's negative 2 times 2, which is negative 4. Negative 4 plus 5 is 1. Okay, so when my x is 6, my y value is 1. Okay, I need one more, and here I see that my x's are increasing, my y values are decreasing, so it's a decreasing function. So maybe I will choose another value, 9, which I expect will put me into negatives right here. Let's see. So f of 9, again, 9 is a multiple of 3 because it will be canceled out. Negative 2/3 and then 9 plus 5. So 3 goes into 3 once, and 3 goes into 9 3 times. So I have a factor of 1 left behind and a factor of 3 left behind. So that gives me negative 2/1 times 3/1 plus 5. So this is negative 6. Negative 6 plus 5 gives me a negative 1. So now I have enough points to plot them onto a graph. So here's my graphing paper, and let's start with 0, 5. No, it's right here. Sorry. 0, 5. And then 6, 1. And then the next point is 9 and -1 right here. Let's see if they line up. And yes, they line up perfectly. So I can graph my function. And it's always important to label your functions. So this is f of x equals -2/3 x plus 5. And you don't have to always write an equation for the function. You just, if you have several functions with different names, you could just write the name of the function. And I would like you to try graph this function by plotting points. Go ahead and try it, and let me know if you run into any problems. All right, I assume that you tried it out. Let me know how it went. Now we're on to example 12 from the handout, and it's another technique. It's called graphing by using the Y-intercept and slope, which is a little bit faster than plotting points. Plotting points is always good, but when you know kind of a background about those equations, it could be just faster to use the information from the equation. So what do we know from this equation? Well, first of all, we know that the y-intercept is 5. So 0, 5. And then we also know that the slope of this function is -2/3. Okay, so let's see how we use this information to graph our function. So first of all, you're gonna start with 1 point on the line. This is very important. The first point that you start with should be on the line. And one point that we know that's on the line is your y-intercept 0, 5. So you start by plotting that point. It's right here. And then starting there, it says the slope is -2/3. So first of all, I want you to notice that this function, it goes down. Okay, it goes down, it's decreasing. And we can attach this negative to either the numerator or the denominator. I always suggest that to put it in the numerator in order not to get confused, because we're moving from left to right. Like if you attach the negative to the denominator, that means that you're going to the left instead of the right, because this is your horizontal movement, right? This is your vertical movement. These are your y's, vertical displacement, and this is your horizontal displacement, the x's. So delta y over delta x. So we want to move from left to right always, so that we don't get confused. Now on the y, because it's a negative value, it tells you that you're moving down instead of up. Okay, but on the x, it's still left to right. Now one mistake that I see very often here, when students see a negative here, they're moving down, and they're also moving to the left instead of right. Okay, so this negative, it attaches only to the numerator or only to the denominator, but not both, okay? So I just want to make sure -2/3 equals to -2/+3 or +2/-3, but not -2/-3, right? So this negative, it reverses either direction up or down or left to right, but not both. Okay, so with that said, we have a point of 0.5 here, and so the slope says that in order to get to the next point, we need to go 2 steps down and 3 steps to the right, and this way we're going to end up on the line again. So let's do this. 2 down, 1, 2, 3 over. Okay, so this is my next point on that line. And you can do it as many times as you want. So you're staying on the line right here. So I already have 2 points, so that's all I need in order to 2 points define a line. So I can actually draw my line here. But if you want to be cautious and you want more points, you can do that, but just keep using this slope. So as long as you start with the point on the line, you can always go 2 down again and 1, 2, 3 over. 2 down, 1, 2, 1, 2, 3 over. You are gonna stay on the same line. So you can actually make a few lines, a few points this way, and just put the line through them. Now, one thing that I want to emphasize now is that you have to, when using slope, you have to start with the point on the line. Okay, it doesn't have to be Y-intercept. Y-intercept in this case is the most convenient one because that's the one that we know right away from the equation. But if you're on the line, let's say here, you could still use the slope to get to the next point. Okay, so that's allowed. What is not allowed is to start at 0, 0, unless that's the point on the line. And that's a common mistake that I see, that students, instead of starting with a point on the line like a Y-intercept, they start at 0, 0, and they start going 2 down, 3 over from 0, 0. This is not the point on the line. And so that would be a mistake. So watch out for that. And our last example in this video is to write an equation of the line given in the graph. So read the graph, convert it into an equation. So again, in order to do that, we need to know 2 things: slope and the y-intercept. And here, the y-intercept is 0, 4. So from here, I know that b equals 4, and also I need the slope. So the slope, you could pick 2 points and go through the formula if you want. We already did that. I'm not gonna do it this. I'm not gonna do that this time. What I'm gonna do, I'm gonna just count how many steps up and to the right or to the left I have to make in order to get to the point that I need. So if I'm here, this is -2, 0. In order to get to this next point, I have to go 4 up. 1, 2, 3, 4, and then 2 to the right. So up is a positive direction, so positive 4. And to the right is also positive direction, so 2. So that's how I know that my slope is 2. That's another way to figure out your slope, it's actually the same thing that we did before, just less formal. Okay, one word of caution here, make sure that you know how many steps you're moving, because here only it goes by twos, right? So from here to there, it's not one step, it's actually two steps. So same as from there to here to the origin, so that's two, not one. So make sure you watch out for that. Other than that, it's that simple, right? So once we know M, and B, then we can write our equation. It's f of x equals m2 times x plus b, which is 4. And that's it. You're done. All right. So that was our review of graphing functions, linear functions. And let's go forward, and we're going to talk about some special functions. Never mind, I decided to do it in the same video. So some special linear functions that we have is the constant function, just like we mentioned, that has a 0 slope, right? So f of x here is equals 5, or y equals 5, same thing. So there is no rise and run. There is no rate of change. It's constant. Rate of change is 0. So in this function, it runs parallel to the x-axis. So it's not going to be not going to have x-intercepts. It only has a y-intercept, right? Y-intercept is going to be here, and it's whatever the function value is. It's 0, 5, 0, 5. Again, it's a point, so don't forget to include the x coordinate. But if you were to make a table value for this function, it would be, your y value would be constant. No matter what x is, y is always the same. So if x is 1, then your y is 5. When x is 4, the y is 5. So guess what y would be if the x is 100? And if you said 5, you are correct. So no matter what x is, x could be anything, the y would still be 5. That's a constant function. All right. Here's another special case for linear functions. It's a vertical line. And in the previous one, in the horizontal line case, we had y equals 5. That was the equation of the horizontal line. Now the equation of the vertical line is x equals a number, and could be anything. Could, like in this instance, it's 2. Okay, so this is a vertical line. It doesn't have y-intercepts, so no y-intercept. It only has the x-intercept, and the x-intercept is the same as the equation, x equals 2, except it's gonna have the y-coordinate. It's a point that involves the y-coordinate of 0. So we're gonna have x equals 2, and the y is 0. So that's the point right here. That's the x-intercept. Now, again, if you were to write an x and y value, this is interesting because for x, actually, you don't have a choice. This says that x is always 2. So like in the previous examples, we were choosing different values for x. For this one, you don't have a choice because x is fixed to be a 2 always. It's constant in the x department. So no choice for x, but y on the other hand can be anything. So it's x to y 2, x to y -5, and so forth. So y is anything, x is always 2. Now the question is this a function? Think about it. And I hope your answer was not a function. This is not a function. Because, and the hint is too, is that x cannot, this is not an explicit function of y. You cannot write it as y equals and a function, right? An equation. So there's not even no y there at all in the equation. So that's a giveaway that it's not a function. All right. So if I asked you to write an equation for this function, so for the horizontal line, you would tell me it's always whatever the y-intercept is, -4, right? It's a constant function. And for the vertical line, whatever the intercept is x equals 7. That's it. I don't know why they put f there. It's not a function. Okay, so one thing about, since we're talking about rate of change and slope, what would be the slope of this function, of this line, rather? So here we said that there is no change, right? So the slope is 0. What's the slope here? And to help you answer that question, let's recall that slope is y2 minus y1 over x2 minus x1. So if we were to choose 2 points here, let's say this point is 5 and -6. And this point here is 5 and +8. Let's say we used those points to calculate the slope. So y2 is 8 minus a -6. And on the bottom we have x2 minus x1, but look, they're the same. So we have 5 minus 5, and that gives me 14 over 0. And what's 14 over 0? I'll give you a second to think about it. And I hope that you guys answered that division by 0 is undefined. It's not a 0. It's not a 1. It's undefined. Nobody knows what it is. Division by 0 is undefined. It's a big no-no in mathematics. And in calculus, you guys will go over great length to avoid division by 0. So please remember that division by 0 is undefined, and therefore the slope of the vertical line is undefined. All right, and that's it for this video now. And in the next video, we're going to talk about parallel and perpendicular lines.